Hello, welcome to this channel. My name is Enoch. Today we will continue our series on Linux. We'll be looking at file permission. To access every file or directory, we know that permission will be needed. A file belongs to a user and a user belongs to a group. And there are things that we need to do to give permission to every user in the system to be able to access a file. Linux is a multi-user system, and the files and directory can be protected from unwanted user by setting their permission as required. Every file belongs to an owner and a group, and we can check the owner and group of a file by running ls-l with the file name. Let's look at that practically. If I run ls-l/, we can see the owner of the file, we can see the group of the file, and we can see the permission. The first character there we know is the file type, and the remaining 9 characters here are the permission. All right, let's continue. There are 3 types of permissions. We have the read permission, which gives the permission to read a file or list directory content. We also have the write permission, which is abbreviated with W, and it gives permission to write a file or create and remove file from a directory. You also have the execute permission, which has the abbreviation of X, and it has the permission to execute a program or to CD into a program. And you also have no permission at all. Let's see that. You can see this. Let's copy these and let's copy these and let's just understand this. Let's use our notepad. Let's put this here. And we know that the first D there is a file type. This file type is directory, and the next 3 is state the permission for the owner of the file or the user, the owner or user owner. I would like to call it owner. And the next 3 is for the group. The next 3 permissions are for the group, and the last one are for others. So the first one there is for the owner. That means the owner has the read, write, and execute permission. The next 3 is for the group, which means this anyone in this group has the read and no write permission, but has the execute permission. For these others, for others too, for any other user in the system, also they will have the read and execute permission with no write permission. So let's just note that when you see it like that, first character is a file type, the next 3 permission belongs to the owner of the file, the next other 3 permission belong to the group, and the last 3 belongs to any other user in the system. All right, let's go back to our slide. So R is for read, W is for write, X is for execute, and if you see just hyphen there means no permission. That's just that, no permission. So everywhere you are seeing hyphen, that means no permission. Group has no write permission here. Others have no write permission here, and so on and so forth. This one means that only the owner of the file has the permission to read, write, and execute on the file. Every other person, the group and others, does not have any permission. So, and we can easily amend all those things. All right, and there are stated permission for every file, as we've seen. Each permission can be controlled at 3 levels: the user level, the group, or the others. And we can see the permission for each file by running ls-ld with the file path to check the permission of the file. You can say ls-ld/temp and it will show you just for temp file. Okay, this is the permission for the file, this is the owner, just so the details, more details of the file. So that's that. You have U for user, G for group, and O for others. So let's move on. Changing file ownership. Only root user can change the ownership of a file, and only root or the owner can change the group of a file. And you can use chown to change a file's owner, and you can use it like this: chown username with a file path. You can change also the group of a file by using this command group, and you can use it like this: group name with a file. And use option R when dealing with a directory that has subdirectories and file. So I think we should see how that is done. Let's create some user in the group. Let's create some user. Let's clear our screen. Let's create users in the system, and let's say user add -m to create a home directory, and let's say Camry, and let's say Avalon, and let's also create Civic. And if you ID them, you can see Camry, you can see that, you can see Avalon too. You can see Civic too if you want. And let's create a group add. Let's name this Toyota. Okay, now we have a group called Toyota. If you run cart/etsy/group, you will see that a Toyota group has been created, a Civic group, an Avalon group, a Camry group. All right, let's clear our screen. If you also run /PSSWD, you will see that Camry user has been created, Avalon and Civic 2 has been created. So let's add Camry and Avalon to the Toyota group. Let's do that. See, use user mod -AG and let's add this to the Toyota group. Toyota group. Let's add Camry. And let's also add Avalon. All right, now both has been added. You can use user mod to just change your to add a supplementary group list, or you can just use group to change the group totally. But I don't want to change the group totally. If you are using this, you use grp, and you give your group name, and you give the username. You run it like that, and it will change the group. But I don't want to change the primary group. I just want to add it to a supplementary group. And if you run ID Camry now, you will see that Camry also now belongs to Toyota. And if you run ID Avalon, you will see that Avalon 2 now belongs to Toyota. So Avalon. But if you run Civic, you will see that Civic only belongs to Civic group. All right, Civic only belongs to Civic group. Okay. So let's continue. So so we can use chown to change a file's owner. Let's create a file. Let's say touch. Or let's mkdir slash term. Let's create it in term, and let's call it Linux directory. Linux directory, and let's create this. And then if you run ls/term, you will see that the Linux directory is there. See that the Linux directory is there, and I can decide that, okay, let's check the ownership of this Linux directory /term/Linux directory. Let's check the full permission. Put D there. You can see you have DLW, you have read, write, execute for the owner of the file. You have read and execute for just the others. You have read and execute for the group, and you also have read and execute for others. This file is owned by the root user, and it also belongs to the root group. But I'm going to change the group now. I'm going to change the group. Let's change the owner and the group, chown, and let's change the owner to Camry, and you can put colon, and let's change the group to Toyota, and what's the name of the file, /term/Linux, and this is going to change the owner. It's going to change the owner, and it's also going to change the group. You can use colon like that to separate it, so it will change the owner and change the group. Just press enter, and if you run your LSD now, you will see that that's changed. Now this file belongs to Camry, and it also belongs to Toyota group. You can see before it was in the root. It belongs to the root user. And it also belongs to the root group. Now it now belongs to the Camry user, and to the Toyota group. So I just want you to know that. Now the next thing, I want us to set password for Camry. Let's set password for Camry. Let's set password for Avalon too. Avalon. All right. Now we'll set password for Avalon. Let's set password for Civic too. Now we have set password for the three users that we have just created, and now let's log in into Avalon. SU-space Avalon. If you log into Avalon, okay. Now we've logged into Avalon. If you run touch slash. Let's first look at the permission of this file. Let's have /term/Linux directory. Let's look at this. Let's put D there to see the permission. Okay, now we can see that there's a read, write, and execute permission for the owner, read and execute permission for the group, read and execute permission for others. All right, let's go back to our slide so that we don't miss anything. We have finished this slide. So chmod to change. Okay, we can change file permission. There are two ways we can change permission to a file. We can change it using the symbolic method, or we can use the numeric method. Let's look at the symbolic method first. Chmod is the command to change access to a file, and you can use your option R when you're dealing with a directory, so that to change the permission recursively, so that all the subdirectories and file permission will also change. So example of how you can do that symbolically is chmod is for others. That means you plus is to add and minus is to remove. Plus and WX, that means you want to add the write permission and the execute permission to this particular directory. And this one, you see, you want to add permission for the user, the group, and others. You want to remove execute permission for users, group, and others. That's what this one is doing. So let's try that for this particular Linux directory that we created. Let's remove all directory. Let's remove all permission for others, and let's give write permission to the group, and run chmod. Let me change back to the root. Let me change back to the root user. So let's say chmod write for the group. That's G plus W, and we have /tem/Linux, and this is going to give write permission to the group. Press enter, and if you run your ls, -ld/tem/Linux directory, you will see that it has given a write directory to the group. Now let's remove the read and execute permission from others. So we're on chmod. This is for group. This is for others, and we want to remove the read and execute permission. And the file is tem/Linux, and this will remove the read and the execute permission from others. And let's run our command again to check permission, and you can see that others now don't have any permission. The group and the owner has read, write, and execute permission. And let's try and see how this works. Let's change to Avalon. Let's change to Avalon. We know that this Linux directory file belongs to Camry, and it belongs to the group of Toyota. So let's change to Avalon. User. We know Avalon belongs to Toyota group. Avalon also, we change Avalon to belong to Toyota group. If you run ID, you will see that Avalon belongs to Toyota group. All right, so you can just run touch/tem/Linux directory / what's the name of the file we want to? Let's say Linux file. We want to create this file. That's what we are trying to do. You can see that file is created. That means that that's a proof that Avalon has the right permission. Avalon has the right permission. Now let's try and prove that it has execute permission by trying to cd into that file, tem/Linux. Run this, you will see it can get inside this Linux directory. That means it has the execute permission, and we have proven the write, we have proven the execute. We now need to prove the read permission. Let's run ls to see the list. You can see the fact that you can run ls means that it has the read permission too. So it has the write, it has the read, and it has the execute permission, because it belongs to because the Avalon user belongs to the Toyota group. Now let's change to the Civic user. Let's change to the Civic user. All right, now we know that civic user only belongs to the civic group. It does not belong to the Toyota group. And let's see what this file can do. We know it does not have the permission to access that particular file in temp directory, because this civic is orders. It doesn't belong to the group, so it's orders. So if we try to create a file in it, you will see that we'll get permission denied. If we try to cd into it, say permission denied, because it does not have execute permission. It does not have the write permission. Let's see whether it can list content by running ls, and you will see that permission denied. It does not have so others does not have the permission to read or to write or to execute on this particular directory, and that's what I want us to note. So let's clear our screen. Let's go back to our shell. So that's that for changing file permission in a symbolic way. Let's look at how we can change file permission numerically. Numeric method uses 3-digit modes, and the first digit specify owner's permission, and the second digit specify the group permission. The third digit specify others permission. For example, if I say chmod and I say 640 with the file name, it means that I am giving. All right, let's look at this. The number with permission assigned. Okay, 0 is for no permission, 1 is for execute, 2 is for write, 3 is for write and execute, 4 is for read, 5 is for read and execute, 6 is for read and write, 7 is for read, write and execute. You don't need to memorize everything like that. Just make sure you note 4, you note 2, you note 1. So you can just combine it from there. So if you see chmod 640 with file name, it means that the owner has the read and write permission. If you see just 4 for the group, that means the group has just the read permission. If you see 0, that means group others does not have any permission. The first digit there is for the owner of the file. The second digit is for the group. The last digit is for others. So others will not have any permission if we run this command. The group will only have the read permission, and the owner will have the read and write permission. Okay, so that's just that. Let's go to our shell and let's see how this works. Let's have an example of this. So I can run. Let's run our file again. ls-temp/linux. If you run this, you will see others does not have any permission in this. Group and the owner, they have read, write and execute permission. Let's change that. chmod, and let's just run 640 that I said earlier, 640, and let's give the file name temp/linux, and let's run it like this. So this will give read and write permission to the owner, only read permission only to the group and no permission to others. Run it, and if you run your permission command again, you will see that you can see read and write for the owner, read only for the group, and no permission for others. Okay, now if I want to, let's do some other thing. Let's do 777. 777 means that, okay, the owner has read, write and execute permission. Everybody, the owner, the group and others will have read, write and execute permission. Let's run this and let's check it. You can see now everybody has read, write, the owner, the group, others, everybody has read, write and execute permission. You can see that. Let's do another example. Let's just give just the execute alone to everybody. Let's check it, and you see only X, everybody only has permission to execute. And can you see? So so let's change it to what it was before. It was 7, and we have read and execute. It was 5, and it was 5 again. Read and execute, read and execute, read and execute. Okay, and if you run it, you see the owner has read, write, and execute. The group and others just have read and execute. So that's that about today's lecture. Just pay attention to it, please, because you definitely will need it in your daily work as a DevOps engineer or as a cloud engineer. You'll be working with a lot of Linux files and directory Linux machine, and you will definitely need to know how to do this. So that's that. Chmod, symbolic, method of changing file permission, numeric method, master them, changing file ownership, chown, chmod, don't forget that, user, group, and others. Don't forget ls-ld. It's very important. If you run ls-l alone, you will not get you will not be able to see, possibly be able to see some permission if you put the file part. But if you put the d, you'll be able to see the file and the permission. So note this d with it. So that's that for today, and we can do some cleanups. We can do some cleanup. Okay, let's run sudo -i. Let's delete all the users we have created today. User del -r to remove the home directory, and let's Avalon. Let's remove Camry. Let's remove Camry, and let's remove Civic, and let's remove the group, the group directory that we created. We created Toyota group. All right, so let's clear our screen. So that's that for today. You can run each tree to check all the commands that we have run today, and you can run them again and again and master them just so that you can have them handy. So that's that for today. I will see you in the next video.